When DAPS finishes the batch analysis process, it automatically switches to the results table. In this table, each line will correspond to a different FWD station, and each column will correspond to a different parameter. So we can see that we have parameters being listed such as distance, the time of day at which the tests were made, the pavement, the number of the pavement section that is being considered for the back calculation process of each individual FWD station, the air and surface temperatures if available, and then we go into the area where the results of the back calculation themselves are depicted. So we have the root mean square error, RMS parameter, and the absolute mean deviation parameter, which are measures of the error that was determined between the solution that was obtained by DAPS and the actual deflection ball on that was measured on the field. So for each set of layer moduli, of calculated layer moduli will correspond a theoretical deflection ball. And these parameters that measure the error compare the theoretical deflection ball as determined by DAPS with the deflections that were measured on site. So it's comparing an actual measure that was collected with the FWD equipment with a theoretical result. And by comparing those two deflection balls, we are we can quantify the measure of error between the theoretical solution and the test measured parameter. Each column that begins with the letter E corresponds to a different layer and its associated moduli. ESG stands for moduli of the subgrade. Then we have E1, which will be the first layer placed above the subgrade, and E2, that is the second layer above the subgrade. So in the current case that we are using as an example, if you recall, we are only using two distinct layers above the subgrade. So E2 will be the asphalt layer, and E1 will be the granular base. DAPS has a maximum number of layers above the subgrade in the batch analysis procedure and in the FWD analysis module of 4. So there's a maximum of 4 layers above the subgrade. In this case, we are only using 2, and that justifies the occurrence of 2 empty columns because they correspond to the layer slots that are not being used. So in this case, ESG is always the subgrade. E1 in this case is the granular base layer, and E2 corresponds to the asphalt concrete layer. If we switch to the post-processing tab, we have a statistical analysis of the results. So you can see that for section number 1, and in this particular case, we are only using one section because the pavement structure is homogeneous from begin to end, from the distance 0, the distance at which the first FWD station is located, to the distance at which the last FWD station is located. There's only one pavement structure, so the structure is homogeneous and constant. And DAPS automatically performs a statistical analysis of the result. So we have so L stands for layer. Then we have asphalt concrete. In this case, we have a 2-layer system above the subgrade. So we have SG stands for the subgrade, GB stands for granular base, and AC stands for asphalt concrete. So the average back calculated results for that particular FWD raw data file are these. These are the absolute minimum, and these are the absolute maximum. And here we have a statistical analysis that corresponds to the 15th percentile. So let's say that instead of the 15th percentile, I want to work with, or I want to determine the 20th percentile. It's very easy. All I have to do is come up here to the 20th percentile, to this field here, and select 20. And automatically, when I change the target percentile, DAPS automatically refactors this column here and presents the result. We also have this particular graphic here that is basically a visual representation of all of these back calculated moduli. So we can, in this graphic, we can see that we have a color scale for the back calculated layer stiffnesses, and as expected, we see that the higher value calculated moduli correspond to the asphalt concrete. You see that there's a clear division here between the lower face of the asphalt concrete layer and the upper face of the granular base. And we can also see that another measure of error or of the quality of the back calculated data is the correlation between the back calculated moduli of the subgrade and the measured deflection at as recorded at the last sensor of the test. So in this graphic here that we are visualizing, we can see that in the green line corresponds to the deflection deflection in the last sensor, and the orange line corresponds to the back calculated layer moduli. And we can see that these two lines practically imitate each other. So there's a very good correlation, in this case minus 96.57%, and this correlation is negative because, as you know, the 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 the, the, the correlation between deflection and layer moduli is inverse. The higher the deflection, the lower the back calculated stiffness will be, and the actual stiffness of the layer itself will be. That's why this correlation is negative, but a correlation of 96 point, it really doesn't matter the sign. A correlation of 96.57%, it's always, in every situation, a very good correlation. It's important to say that if we right mouse click on any location in this table, we'll make this pop-up menu show, in which, if we use it, we can copy the contents of this table to a spreadsheet, for example. But there's always also another solution to save the data, which is to go up to the batch analysis menu, then select the option save results to file, and I'm going to call this automatically creates a spreadsheet file that I'm going to call first FWD results and save. So DAPS provides me with this message stating that it was able to successfully save the data. And if I try to open it, you'll see that this is the file that I just created. So if I open it, all of the information that I have for that I had before, that was being shown to me by DAPS, is available in this spreadsheet. So once again, to each line corresponds a different FWD station, and to each column will correspond a different parameter. The statistical analysis that I showed you before is also available if you scroll down. And if you move to the sections end of the sections worksheet, DAPS automatically writes to file the pavement section that was being considered.